Right, I'm asked to sketch y equals root x. This only exists for positive values of x, and this is what it looks like. Note if you were to carry it on for negative, for negative, like plus or minus root x, and it actually looks a lot, it is a parabola essentially, but rotated. So you can always try to like link the two together because they're inverse functions after all. Your y equals x squared. You do actually you'll cover this in second year, but technically you have to remove the negatives, but then the inverse function ends up looking like that. But just try and remember it's like a parabola but on its side, and then we're sorted. In part two, we're asked to describe the transformation that takes root x to root x minus 4. Well, essentially this is f of x, if f of x was root x, going to f of x minus 4. The minus 4 is like within the function rather than out here, and that makes it a translation in the x direction. So translate, describe the transformation. It's a translation by, and I always use a vector here. It's going to be 4, 0. Because there's a minus 4, this becomes positive 4. I go into detail on this in other videos. I'm not going to do it here. It's when it's inside, it's basically the opposite. So translation by 4, 0, and that's it actually. You could also say 4 units in the x direction, but a vector just kind of writes that more concisely. Finally, we're told that the curve y equals root x is stretched by a scale factor of 5 parallel to the x-axis. So it's still the x-axis. State the equation of the transformed curve. Now, if it was the y-axis, it would become 5 root x. It goes on the outside of the function. When it's the x-axis, it goes on the inside, and it's again the opposite. So, I had the plus. When it was a positive translation, I had a minus. Now it's a stretch of 5, it actually becomes x over 5. So that is my transformed curve.